So this one gets confused a lot. How many different ways can I put book 1, 2, 3, and 4 onto the shelf? Do you think there's only one way I can put them up there? There's a lot of ways I could put them up there. How many choices do you have for this spot? 4. How many choices for this spot? 3. How many choices for this spot? How many choices for this spot? So did the order matter? Yeah, it did matter. When you're putting books on a shelf, the order matters. Don't tell me it doesn't matter, because if I rearrange it and I grab the one at the end and put it at the beginning, it's different. So the order matters. And that's a P problem. This would be 4P4. If the order didn't matter, it'd be 4C4. Questions on that so far? So this is the kind where the order matters. And it would look like that. Okay, now is there another way to do it? Absolutely. If you have got your calculator with you, grab it and take it out. If you're one of the kids that's been relying on the iPad, there will be a calculator at least for every group. Okay, but hopefully you've got your own calculator. Or you could use the iPad calculator for now. You just can't use the iPad calculator on the test. So this would be 4 NPR4. Just make sure you know where that is. It's under the math menu and probability. 4 NPR4. Do it. See what you get. Sage, what did you get? Okay, so you got to go find it on your iPad. It's in the folder called Welcome, and then there's a yellow folder that says click here for a calculator. All right, Ellie, were you able to find it on your calculator?
I'm getting a calculator.
All right. Let's go to somebody.
I have it right here.
Okay. Almost done? That'd be great. I can wait.
24.
All right, and it is 24. And I want you to just see that this would have worked. 4 times 3 is 12, times 2 is 24. That would have worked. Okay, so for P problems, that's like multiplying your choices. You had 4 choices for who could be in that spot in line, 3 choices, 2 choices, 1 choice. All right, now how about C's? They're different. That's 4 NCR4, and that's different. It's not going to be the same answer. Would you please go find 4C4? Check and make sure you know how to put this in. Sayer, you got this already? Matea, what'd you get? Still typing. Okay. Got it? What'd you get? 1 is correct. And if you think about it, if you have 4 things and you choose all 4 of them, how many different ways can you do it? 1. There's only one way to do that. What if the order mattered? Well, then it'd be a P problem and it'd be different. P problems have much bigger answers. Okay, so let's do another one that's like that. There's you and let's make it a total of 5 kids total, not just you and 5 kids, but 5 kids total. And you're swimming. And you decide to do a swimming race to a raft. And all you keep track of is first and second place, because it's kind of complicated if it gets to 3rd and 4th. But it's easy to tell who's first and who's second. How many different ways could you finish first and second? You have to figure out, is that 5P something or is it 5C something? It's a race. I'm going to pause for a second while you work it out. All right, Taylor, what did you do?
I did
5P2. Why 2?
because there are only 2 places that matter.
Only 2 places matter. Why a P and not a C?
Because the order matters who gets first and second.
Very good. And if you did it with a calculator, it's pretty easy. But if you had to write it like this, will you have to write it like this? No, but you'll have to understand what this means. 5 factorial over 5 minus 2 is 3 factorial. That's how you get that kind of answer. Do you know what that means? If you don't, you're about to lose points on this quiz. So pay attention. It means 5 times 4 times 3 times 2 times 1 over, what does 3 factorial mean? times 2 times 1. Good. And these would cancel, leaving just 5 times 4 is 20. Would that be different if this had been a C problem? Absolutely. Here's a C way to do it. Just let me show this quick and then I answer your question if you still have one. 5 factorial over 5 minus 2 is 3 factorial. With the C problems, look, there's an extra one of these right here. See how C problems are a little more complicated? Would you please write out what that one means? This is something you have to know for the test. What does this mean? I have an example one up here that's a little different. I'll pause for a second. You give that a try. All right, you should have said 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 with an extra 2 times 1. And by the way, if you don't know, there's a times in between them. So like there's a times right there. It's all times on the bottom. Then what cancels? 3, 2, 1 and 3, 2, 1. And 5 times 4 is 20 divided by 2. Final answer 10. Raise your hand if you had a 10. Okay, good. Could you have done that with just this on your calculator? Yes, but there's going to be one part where we expect you to tell us how to make one of those. So hopefully you saw how that was made. This minus this made that. Let's see if you can do it. Write out by hand what this means. 7C6. Agree as a group. What does that mean? And no, you can't use your calculator on this one because you have to be able to set up the factorials. What factorial over what? Factorial over what? Okay, this one would have been 7 factorial over 7 minus 6 is 1 factorial. But wait, there's an extra 6 factorial. That'd be easy to forget. Do you get how that worked? 7 minus the 6 made the 1 factorial here. Plus, there was an extra 6 factorial because of that. So final answer is 7. Raise your hand if you had 7. Okay, and what does that mean? Combinations. That's order doesn't matter on that count. Okay, so if I ask you to rearrange the letters in cow, can they be rearranged? Does that imply you're saying C, O, and W could never be any other way? Well, you could rearrange them. I'm not saying that they have to be real words, but I could rearrange them. W, O, C is totally different, isn't it? So that's a different arrangement. How many different arrangements are there? Talk to your group. See how many you think there are. Pausing. There are many different arrangements of this. I could just say 3, and a lot of people just thought it was 3 times 3. No. It's either 3C3 or it's 3P3. And which one does the order matter? 3P3. And then you could do that with a calculator, or 3 factorial over 3 minus 3 is 1 factorial. That would just be 3 times 2 times 1. The answer is 6. Raise your hand if you had 6. Okay, good. All right, so rearranging a word, does the order matter? Yes, it does. Okay. You're in line for tickets at a movie. Does the order matter?
Yeah.
Yes, because some people aren't going to get tickets. Or nowadays, there's like really good seats in the middle, and then sometimes there's a ticket left, but it's bad and it's way up in front and you have to crane your neck, and so sometimes the order, it matters even in a line, because first in line gets to buy better seats. Okay, so next let's talk about expected value, and you're going to have a question about expected value. Here's an example. Let's say that there's a spinner, and let's say that it's divided this way. And let's say this is $100. If you get that, is there a good chance? Yeah, it's half the spinner. But then these 3 are each 1/6 of the circle. Okay, and this one's worth $20. This one you get a 50, and this one you get a 10. Would you agree that it probably would be worth $10 to play this game because the expected value will be at least $10 or more, right? And $100 would be dumb because you'd lose your money half the time you'd lose your money, okay? The other half, you just get it back. So your price that's expected is in between $100, which would be ridiculously bad, and $10, which would be a ridiculously good deal. Somewhere in between there is the expected value. I'm reminding you that I did P times A and then I added them all up before. See if you can figure out the expected value for this one. Pausing. Okay, Sam, tell me how you started this problem.
Half times half.
That's the probability times what? Half times what?
Half.
Nope. This is 100. 1/2 times 100.
Oh, yeah.
And that makes it $50. And then you add the next one. That's half of 100 is definitely $50. Okay, and then the next one is 1/6 of 20. Probability times the amount. And then 1/6 of 50. And then 1/6 of 10. If you did it wrong, I'm going to give you a little time right now to fix it, because that's how you multiply them, and then you got to add them all up. I'll pause for a minute, see if you get the right answer. So this came up to 63.26. You got your grand total. That's what? What is that called?
Yeah, you're gonna do it.
What is it?
It's the,
2 words. Starts with an E.
estimated value.
Expected value. That means that they expect you will win $63 on average playing this game. So, do you think they would charge you $63 to make it totally fair?
More.
They would charge you more because the house wants to make a profit. So if it was a casino, they might charge you like $65. It might only be that much different. Not way off, just a couple percent. Okay, then, last thought. We've done expected values, we've done P's, we've done C's, we've done the kind that have, I think we've done everything. So you're now going to take that quiz with the help of the people that I put you in the group with. You've got typically groups of 3. And remember that the rules are that you have to work together, but you don't have to agree on answers. But if there's a certain one you disagree on, you need to talk to them about it, make sure they know that you disagree, because otherwise this is going to be graded differently. That's all I got for the video for today.